Good day and good evening, everyone. I'm Davidson and Robert, and 190143. I will be presenting the final year project. The title is The Design and Development of Hybrid Mini Hydro Solar Fountain for Power Generation. This is the contents that I will be presenting. Introduction, Chapter 1, Chapter 2, Chapter 3, Chapter 4, Expected Result, and Conclusion. Introduction. The hybrid mini hydrosolar power fountain project is a system that will generate electricity using turbine for hydropower and photovoltaic panel for solar power. The power then will be stored into a battery pack and will be able to use for load like smartphone charger, lamps, and socket outlet. Chapter 1, I will be presenting about the problem statement, objective, and scope of study. This is the problem statement. First is the electrical energy produced might not be enough to support the output load like smartphone charger, lamps, and LED. Second is a proper design that are energy efficient. If the design are not designed properly, the energy that are produced will not be efficient. For example, the turbine, if it's not correctly designed, the turbine will not be able to use the full potential to generate electricity that are high enough to support the load like smartphone charger and etc. Third is small design that enough to support multiple load. As we can see, the bigger project, hydroelectric project, it is a big project that need outdoor area, so it will have powerful water stream to run the turbine. So a small design of the project is a important matter. Next is objective. The first objective is to develop a hybrid mini hydro solar fountain and generate eco-friendly electric power. Second is to analyze the data of electrical power used against power generated by the system over time. Third is to evaluate the performance of the hybrid mini hydro solar fountain for power generation. Next is scope of study. The scope of study is designing a good hybrid mean hydrosolar generator that uses a limited amount of water to keep it running continuously. Second is constructing an efficient hybrid mini hydrosolar generator system that produce enough electricity and can support loads like phone charger, LED light, sensor, mini fans, and mini lamp. There is also built-in IoT into the system to monitor the system remotely from afar. Also can be used to collect data of the system efficiency. Next is the last one. The output of the system will be aimed to generate a 5-volt current to the load of the system. Chapter 2. In Chapter 2, I will be presenting about the discussion on literature review related previous project study. Okay. Next, discussion on literature review. A lot of ideas that have been gathered to apply on the hybrid mini hydro solar fountain for power generation, such as simulation for the minor part of the project, were the best way to test the circuit to make sure it will work properly. From the previous project study, many of it also use Arduino from the circuit. There is also the usage of battery pack like the one of the requirement in the hybrid mini hydro solar fountain. The connection of the circuit and components part can be referred from the findings and will be make the troubleshooting of the project be easier as it can be read from the article of the previous project studies. An improvement of the project will be consisting of a more efficient way of generating power, so there will be a lesser power loss and enough potential to support the load that may be implemented on the system. The uses of IoT technology will also be used so the data of the system can be monitored from the IoT application. Next is related previous project study. First is solar charge battery powered. Second is solar water tank regulator. Third is distributed electrical resource with micro hydroelectric power plant in Colombia. Design and development of trash trap for stream for mini hydro. Fifth is solar hydro based hybrid power generation. This is the total of my findings of the related previous project study. As you can see, there are only 5 that I can find. Next is chapter 3. I will be talking about project flowchart, system block diagram, system flowchart, circuit diagram, design, software development, and bill of materials. This is the project flowchart of my final year project. First, I will be deciding on the title of the project, and then I will be planning the project, research on past project, also known as research on literature review, and plan the design. All of this will be on the phase 1, also known as final year project 1. And on final year project 2, I will be building the hybrid mini hydro solar power generator system, the hardware, and then I will test the system and check if there is problem. If there is problem, I will troubleshoot the system and test it again, and then check it again. If there is no problem, I will analyze the data and result, and then I will check if the data obtained is satisfying. If not, I will troubleshoot it again and test the system again and check the problem, analyze the data and result, and check the data again. If it is satisfying, I will conclude the project. That's all from project flowchart. Next is the system block diagram. As you can see from the block diagram, there is motor and solar panel. The motor is the water turbine, and it will connect it to the rectifier, and then it will charge the battery. From the solar panel, it will flow the current that are generated from the solar panel to the charge controller to regulate the voltage and current of the current flow to the battery, so the battery will not get destroyed. And then from the battery, it will connect it to Arduino as the power supply. The Arduino will uh, connected to the LDR, light dependent resistor, and then if the light dependent resistor does not detect light, it will turn on the LED. If not, it will turn off the LED. Also, the Arduino is connected to the IoT. Okay, next is the system flowchart. There is two start on the system flowchart. That is the solar panel and the water turbine. We start from the water turbine. If the water spin the water turbine, it will generate electric, and then the electric that are generated will pass to the battery and charging it. And from the solar panel, if the solar panel is laid outdoor, it will detect sunlight and generate electricity. The electricity will flow to the charge controller to regulate the voltage and current, and then charge the battery. From the battery, it will connect it to the Arduino that will detect the dark place for the LDR. If the LDR detects that there are no light, it will turn on the LED. If the place are not dark, it will turn off the LED. And then from the battery, it is directly connected to the output load. Next is circuit diagram. As you can see here, this is my circuit diagram. There is a breadboard, LCD, Arduino, battery, output load, DC motor, and solar panel, and bunch of small components like LDR, LED, potentiometer, and voltage regulator. Next is the design. The design that I made here is by using AutoCAD. This is the 3D design of the project that focus on the efficiency of the energy generation. There are also top view, front view, and side view, and the overall view. Next is software development. The software development I will be talking about the coding. This is the coding that I made for the battery indicator for the simulation. Then I will talk about the bills of material. This is the bill of materials. I calculated the total of the components that I will need to use is totaling an amount of 237 ringgit and 67 cents. Next is chapter 4. We will be discussing about the simulation result and problem and solution. This is the simulation result that I get from using Proteus 8. The potentiometer that are connected to A0 pin is assumed as the battery level gauge module, also known as fuel gauge lithium battery. That is the real-time testing component that I will be using on final year project 2. It is used to detect the battery power available in the battery. The LEDs that are connected to the pin 0, 1, 2, and 3 is the battery level indicator. If the battery are 25% and lower, one LED will turn on. When the battery is 50% and lower, 1 and 2 LED will turn on. At 75% and lower battery level, 1, 2, and 3 LED will turn on. Finally, if the battery level is at 100% and lower, it will turn on all the LED. The LCD display that will display the battery level. The LDR that are connected on A1 pin will detect the darkness in the room and turn on the LED that are connected to the pin 13. If the room is bright, the LDR will detect the room is bright enough and the LED on pin 13 will be turned off. Problem and solution. The problem that has been encountered during the simulation is that the normal battery cell in the Proteus library can be used, so it will substitute for a potentiometer to show the example of battery level on the LCD display and LED indicator for a certain level of battery. Next, the usage of current cut-off component was not be able to use in the simulation, so it will need to be excluded from the simulation and will be tested on the hardware of the project with trial and error at final year project 2 later. Expected result. The expected result of the project is that the project is able to power up all the load on the system with sufficient energy without any problem. As far as the final year project 1 progress, the only thing that has been applied is the one that can be run in a simulation Proteus. The real-time hardware testing will be conducted on a final year project 2 as it is can be tested in a simulation but only work in real-time testing like the fuel gauge lithium battery detector. For conclusion, the project still have many parts and potential that has yet to come since assembling the complete part are not yet being done as in final year project 1. The complete result of the project will be as crystal clear by the end of the final year project 2 because at that time the project will be done and the result that are expected will be so satisfying. That's all from me. Thank you.